Understanding the concepts, multi-speed blower circuit operation. The blower circuit for the air conditioning system provides the airflow to circulate the conditioned air to the passenger compartment of the vehicle. There are two types of blower circuits, multi-speed and pulse width modulation. The multi-speed blower circuit consists of several components. The blower motor is generally housed under the dashboard, on the passenger side of the vehicle. In some cases, it will be located in the engine compartment. The blower is comprised of a fan motor and a squirrel cage fan blade. When energized, the fan spins the squirrel cage circulating air throughout the duct system and into the passenger compartment. The speed of the blower depends on the speed selected and the blower resistor. The blower resistor is typically located behind the glove box in the case and duct system. The blower resistor generates a great deal of heat when the blower is running and should not be removed from the case and duct system during blower operation. The blower resistor is comprised of resistors that are added or removed from the blower circuit depending on the speed selected. For example, if a medium speed is selected, two of the resistors from the resistor block are energized, which adjusts the resistance in the circuit and in turn adjusts the amperage and voltage applied to the motor to control the speed. The power source is the same power source used for the vehicle, the battery. The output of the battery should maintain a constant 12.6 volts. The conductors carry the electricity to the various parts of the circuit. The conductors are sized based on the amperage they will be required to carry for the circuit they are energizing. Sizing of the conductors is important so as not to burn the wires if undersized. The selector switch is a multi-position switch that allows the occupant to select the speed of the blower. The selector switch usually has 4 to 5 speeds depending on the vehicle manufacturer. The circuit protection device, fuse, is located in the underhood fuse box or in the fuse box located next to the steering column. When the amperage in the circuit exceeds the limit of the fuse, the element in the fuse will burn open, stopping all current in the circuit. The AC circuit relay is located under the hood of the vehicle in the fuse box. When energized, the relay passes power to the blower motor. The relay receives power when the key is turned on and the AC control head is set to any position but off. The blower circuit operation. Battery voltage will flow through the circuit starting at the battery, moving through the conductors to the relay contacts and relay coil. Battery power will not pass any further since the relay coil does not have a ground to complete the circuit and the relay contacts are currently in their normal position, open. When the ignition switch is rotated to start or run, the blower relay receives the ground to complete the circuit and energize the relay. When the relay coil is energized, it will become magnetic and pull the contacts down. Battery power will now pass through the relay, through the fuse into the blower motor. The ground side of the circuit will determine the speed of the motor. When the selector switch is set to the highest speed, the blower will receive full battery voltage and have the highest amperage reading. When the speed selector switch is moved to the next lowest speed, the ground side of the circuit changes by now adding one resistor from the resistor block to the blower circuit. Adding the resistor will increase the total resistance of the blower circuit, resulting in less voltage and less amperage reaching the blower, slowing the speed slightly. When the selector switch is moved to the next slower speeds, another resistor is added from the resistor block, resulting in decreased voltage and amperage to the fan, slowing the speed of the fan. This continues through all the speeds as the selector switch is moved to the next lowest setting. Based on the voltage and amperage readings that can be taken on the blower circuit, we can conclude that the higher the blower speed, the higher the voltage and the higher the amperage will be in the circuit. The lower the speed, the lower the voltage and the lower the amperage will be. A pulse width modulation, PWM, blower circuit is used in a system that has the option for an auto climate control or a semi-auto climate control. In these systems, the vehicle occupants select temperature and blower speed, vent outlets, and temperature of the air selected by the body control module, BCM, based on the inputs from the various sensors. The various sensors used in the pulse width modulation system include, but are not limited to, an ambient air sensor, a sun load sensor, an intake sensor, and an in-car temperature sensor. PWM blower circuit operation. The body control module, BCM, sends out a signal to the various sensors in the PWM blower circuit. Based on the resistance of the sensors, a precise amount of voltage returns to the BCM. The BCM is programmed to take these signals and calculate the appropriate blower speed, vent outlet provision, and the mode or position. The BCM sends out a PWM signal to the blower to provide the speed needed to make the passenger compartment as comfortable as soon as possible. The PWM signal that is sent to the blower is based on the on and off, duty cycle, and time during one cycle. Changing the ratio of the on-off time will adjust the speed of the blower. In the pulse width modulation circuit, the speed of the blower can be adjusted to any speed between the capabilities of the motor from the highest speed to the lowest speed. Diagnosing a PWM circuit can be done one of two ways. Some control heads for automatic climate control will have built-in diagnostics. This consists of holding specific buttons on the control head for a specified amount of time. This will let the technician enter the diagnostic mode and manually control the system as well as retrieve any faults. Not all vehicles have this option. The second method is to connect the scan tool and manually go into the AC system and prompt commands to the various actuators. Now enter the simulation to learn more about multi-speed blower circuit operation.